So we are live. So we are going to discuss 2021 leftover questions in the paper HPCL electrical paper. Okay. In the previous session, we discussed some questions. Some questions are left over. Those questions we are going to discuss in this session. Right? Yeah. If you have any question, you can please directly message to me in the chat box. Yes. We'll start. Yes, we'll start. Read the first question, all of you, please. Read the first question. Yeah, read the first question, all of you. What the first question is? Leftover questions. In the previous session, we solved some questions. The leftover questions we are solving. Yeah, a power amplifier supplies 50 watts to an 8 ohm speaker. What that fellow says is saying is there is 8 ohm resistance to this one. 50 watts is supplied by a power amplifier. Yes, there is some power amplifier here. This is power amplifier. Power amplifier. This is supplying how much? 50 watts. To this one, how much is supplied? 50 watts. Right? Find the AC output voltage and AC output current. His question is to find AC output voltage and AC output current. The power is because of RMS value of voltage or current. So what we know that is power is equal to voltage square. Yes, this is AC voltage. In fact, RMS value by R. That fellow given power as 50 watts. That is equal to voltage. I don't know. I have to calculate. By resistance is 8. Resistance is how much? 8. So V square is equal to 400. Yes, 400. So from this one, V is equal to 20 volts. How much? V is equal to 20 volts. So you need to do for the current. Only one option is matching the 20 volt. Option is B. But let's do for current also. Voltage is equal to, say, current is equal to voltage divided by resistance. So that is obviously 2.5 amperes. That is how much? 2.5 amperes. Option is B, B for Bombay. Right? See, but if you think, sir, I don't know about power amplifier, what shall I do? In that way, if you think, you'll commit mistake. So this question is nothing to do with power amplifier and all. It's infrastructure, nothing we need to know. Just if you know the formula, power is equal to voltage square by R, then you'll get the voltage. Current is equal to voltage divided by resistance, Ohm's law, you'll get the value, right? Next question, please. Two equal resistors of 10 ohms each are connected in series. Yes, there are two resistances. Both are having equal resistance of 10 ohms connected in series with a 20 volts DC supply. That fellow is saying that 20 volts of DC is applied. Then simply we can say current of 1 ampere will flow. Fine. Find the current through each resistor. That is, see, you can't find more simple question than this one anywhere. That much simple that question is. Just application of Ohm's law. That's all. Just application of Ohm's law it is. Next question, please. Yeah. See, the following Boolean expression is not visible here. Let me take that expression and write. This question is from digital electronics. This question is from digital electronics. Yes. I will give you some time for all of you to solve. Try to solve. This is the expression. The expression what he given is B plus BC. B plus BC into B plus B bar C into B plus D. Into B plus D. He's asking if you simplify what you're going to get. First of all, let me simplify this first part. what I do, I take B common, then I'm going to left with 1 plus C. 1 plus anything is equal to 1. Yes, 1 plus C is equal to 1. 1 plus 0, 1 plus 1, right? Next, how to simplify this one? This is, we can write like this. A plus A bar B is nothing but, see, please do remember, this is A plus A bar B is equal to, it can be written as this way, distribution property, A plus A bar into A plus B. So A plus A bar is 1. So from that one, you're going to get simply A plus B, right? So B plus B bar C will be B plus B bar into B plus C. So this is B plus C into B plus B, right? So this is 1. This is 1. Now B into B will be B into B will be B plus BC. So this is into B plus D. This is into B plus D. So B into B is B. Yes. B into B is B. B plus BC. I'll take common again B. Then it is going to be 1 plus C. Yes. Into B plus D. Right. This is again 1. Again it is going to happen B into B plus B into D. Let's take B common. Then it is going to happen B into B is B only. If you take B common, it is going to be 1 plus D, that is equal to B, B for Bombay, right? The option is B and the answer is also B. Option is B. In the B option, answer is B. That is a simplification. So having this formula with you is very, very important. Having this formula with you is very, very important. Let's go for the next question. In cathode ray tube, distance of dash is minimum from the phosphor screen. Yes, distance of X plates should be minimum. Distance of X plate should be minimum, right? That is from CRO. Okay, the same question it is. Same question it is. Yeah. Calculate the power absorbed by the 9 kilo ohm resistance in the following network. So this is the 9 kilo ohm resistance. This is VB, he is saying. This is 30 milliampere. Tell me how to solve this one. See, all these questions are of diploma level or ITI level. This question is of diploma level or ITI level. So these questions are not of graduation level. But you know, HPCL examination is one of the easiest examination in India. Okay. So question is very simple. If you want power, what to do? He's asking about the power. So power is equal to, I'll find how much is the current through 9 kilo ohm. So I 9 kilo whole square into resistance is 9 kilo. How to get the current, sir? Current by with help of current division. What is current division? Current through this one, I am naming it as I9K. I'm naming it as I9K. Current through that 9 kilo ohm is equal to total current 30 milli, or let's not write that, let's keep it as 30 milliamperes into, what is current division? If you want current through this one, opposite resistance, how much it is? 18 kilo ohm divided by total resistance, sorry, opposite resistance by total resistance, 18 plus 9, how much it is? 27 kilo ohm, right? 18 plus 9, yes. How much it is? 18 plus 9, yes, it is 27 only. Clear? Now, 3 cities, sorry, 3 or 9 2 cities, 9 3 cities, right? 3 10 cities. So I9K is equal to 20 milliampere. I9K is how much? 20 milliampere. See, I'm requesting all of you, if you get the answer, type it in the chat box. Very easy questions. All questions are very, very easy questions only. No question is having any great thing to discuss. So power is equal to, how much is the current? 20 milli, means 20 into 10 to the power of -3 whole square into 9 into 10 cube, 9K. So 20 whole square is 400. 400 into 10 to the power of -6 into 9, sorry, 10 to the power of -6 into 9 into 10 cube, right? So this is going to give milli. So 3600 into 3600 into 10 to the power of minus 3. It is almost 3.6 watts. Answer is 3.6 watts. Direct question, easy question. It is the easiest question, right? Let's go for the next question. Yeah, few questions are there from control systems also. Please keep that in mind. Few questions are from the subject control systems, right? Read the question. What he is saying. What he is saying. In a signal flow graph, dash is the gain along any path from the input to the output, not passing through any node more than one. See, if I take an example of signal flow graph, yes, this is an example I'm picking here. Yes, right. For example, I'm taking this random signal flow graph. Yeah, so this is node x1, this is x2, this is x3, this is x4. This gain I'm taking it as 1, so this is obviously x4. Okay, here I'm taking this one as g1, this one as g2, this one as g3, this one as g4. This is minus h1, this is minus h2, minus h3, minus h4, right? This is a signal flow graph. Clear? I'm taking one example signal flow graph. What he is saying? He is talking about in a signal flow graph, dash is the gain along any path. See what that fellow is saying, along any path from input to the output. Oh, he's saying you are choosing a path from input to output. In what way? In such a way that not passing through any node for more than once. If you are choosing a path from input node to output node without choosing any node for more than once, or without touching for any node for more than once, that path is called as forward path. Let me write the definition of forward path. Forward path, what it is. Forward path. Let me write. It is the time taken. It is the path, not time. It is the path taken from input node to output node. Input node to output node without touching any node more than once. You should not touch any node for more than one time. Okay, that path is called as what path? Forward path. Now, if we multiply all the gains, in fact, all the branch gains in a particular forward path, then that resultant gain is called as forward path gain. Is called as what? Forward path gain. Come back. Yes. Now he is asking in a signal flow graph, dash is the gain. Yes, is the gain along any path from input to the output, not passing through any node for more than once. That is called as simply forward path gain. That is called as simply what? Forward path gain. Clear? That is called as forward path gain. Let's go for the next question, please. Next question. As per force voltage analogy, yeah, he's talking about force voltage is there, force current analogy. There are two types of analysis. As per force voltage analogy, mass and viscous friction in mechanical translation system are analogous to dash and dash in electrical system respectively. See, in force voltage analogy, mass is, yes, mass is equivalent to what? Yes, mass is equivalent to what? And see, viscous friction is equivalent to what? Viscous friction is equivalent to what? I will tell you. First of all, viscous friction is equivalent to resistance. Viscous friction is equivalent to resistance. You see, resistance, see, resistance, only option A is matching, and this mass is equivalent to inductance. This way, we will forget sometimes which one, see, either inductance is analogous to inductance is analogous to mass, or capacitance is analogous to mass. So at this point of time, sometimes if you are in confusion, we can eliminate this way. So friction is always resistance, either it is force voltage analogy or force current analogy. Friction is always resistance. Viscous friction is resistance. So this is resistance. Therefore, mass is analogous to inductance. Mass is analogous to what? Inductance. That way we can answer this one, suppose if we forget. Right? Next question. Yeah. So this question is from our power system circuit breaker. This is one of the very easy question. What is this question? Yeah. The resultant transient voltage which appears across the circuit breaker contacts at the instant of arc extinction is known as. Yes, anyone, you can type your answer in the chat box. See, I'm waiting for your answer. You can type your answer in the chat box. I read the question again. Yes. The resultant transient voltage which appears across the circuit breaker contacts at the instant of arc extinction is called as restriking voltage. The name itself says. See, that restriking voltage is the reason which is the reason for the restriking of the arc again. Okay, we are trying to extinguish the arc, but because of this restriking voltage, again there are chances for the arc to restrike. Right, that is called as restriking voltage. Next, which of the following is not a deterministic signal? The name itself, deterministic. Yes, which of the following is not a deterministic signal? Option A is sine wave. Yes, sine wave is purely deterministic. Yes, how sine wave exists? What is the appearance of sine wave? See, sine omega t, if you draw it, yes, its value at any point can be determined. It's a finite value, right? It is sine wave. Let me take this one as omega t, and this is x of t. Its maximum value is let me take it as a plus xm. Minimum value, many people will say it as 0. No, minimum value is minus xm. Okay, so that is sine wave. Next, exponential wave. For time being, I'm taking exponentially decaying wave. Or if I take exponentially decay, this way it looks e power minus at, where a is greater than 0. E power minus at, a is greater than 0 means e power minus 2t or 3t, like that it is. Next, let's keep it c aside. Cosine wave. Sine and cosine almost are same, except that phase angle of 90 degrees, right? So this is cosine wave. This should be 0 degrees. 0 degrees or 0 radians. This is cos, right? If I'm taking cos omega t identically, means I'm not taking any maximum value other than 1. Or if you are taking it as xm cos omega t, so at t is equal to 0 itself, this is plus xm, and the minimum value is going to be minus xm. But can you have any particular equation for noise? We do not have. Therefore, noise is not a deterministic signal, right? Noise is not a deterministic signal. Clear? Next question, please. For a transistor, collector current is 100 times the base current. Find beta DC. Yes. IC is equal to beta times of IB. Beta DC times of IB, in fact. See, the question and answer both are same. Answer is 100, that's all. In the question itself, that fellow mentioned the answer. For a transistor, collector current is 100 times the base current. This is nothing but what that fellow is saying. IC is 100 times of IB. IC is 100 times of IB. And what is beta DC? That is 100 only. So very, 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 very simple. You cannot expect more simple questions than this. Even for diploma level entry exam also, questions will be somewhat tougher than these questions. These questions are not my own questions. You can check these questions in 2021 paper of HPCL. 2021 paper of HPCL, right? Yeah. Following circuit is dash clipper. This is somewhat for electrical guys. This is somewhat a question where at least you can think for a second. Okay, you can think for a second. Please try to answer this question, please. Yes, I'm expecting answer from all of you guys. Yes, I'm expecting answer from all of you guys. The following is circuit is dash clipper. Clipper means it is clipping the input. Yes, I'm expecting answer from you guys for this question. As I told, you can type in the chat box. Clipper. Okay, let's see. I'm taking VI input as sinusoidal voltage. This is my input. Now, sinusoidal voltage. Now, you know about the diode. You know about the diode. This is 0. Diode is forward biased for positive half cycle. Yes, if it is plus positive, that positive will come here. Then diode is getting forward biased. Suppose if it is a negative, then diode is going to be reverse biased, right? Diode is going to be reverse biased. For see minus. If for positive half cycle, for let me draw the output voltage V0 here itself. Let me draw the output voltage here itself. Okay, this is output voltage V0. Yeah. Now tell me when the diode is. Tell me all of you when the diode is on for positive half cycle. Diode D is on. I can say D is on. If the diode is on, as it is ideal diode, it is behaving like a short circuit. Yes, in the forward bias, ideal diode behaves as a short circuit. Right? In the reverse bias, it is going to act like a open circuit. If that is a short circuit, how much is the voltage? What is the voltage across short circuit? 0. Therefore, this voltage is 0 up to here. The voltage here is 0. So positive half cycle is clipped. It is not visible in the output. Positive half cycle is clipped. That is not visible in the output. Let's go for negative half cycle. For negative half cycle, this is going to behave. See, this is I'm removing. I'm putting like this. That is going to behave like an open circuit like this. Therefore, the voltage here and here both are same. And here current is 0. Therefore, I can say this voltage is equal to this voltage. If you write the KVL, minus Vi plus V0 is equal to 0. Therefore, V0 is equal to Vi. Means how much that is present at the input, the same is going to appear across the diode because the diode is open circuit, and that is equal to output voltage. So you are going to get like this. Next 0. Next 0. So which part is clipped off? Which part is clipped off? Positive part. So negative is wrong. Negative is wrong. Either option C or D. Shunt. Yes, the diode is kept in shunt. So shunt positive clipper it is. The following circuit is a what? Shunt positive clipper. Option is C. This way simply you can do the analysis. See, one thing you must know, where is the diode? Either it is forward bias or reverse bias. Forward bias means short circuit. Reverse bias means open circuit. Now find the voltage. You draw it. See, positive part is clipped off. Positive part is clipped off, right? Next question, please. Yeah. A continuous time signal is said to be periodic if S of t is equal to x of t plus t naught, where t naught is called as. Yes, what is t naught? This is very basic, fundamental question from signals and systems or mathematics or network analysis or any subject. This is basic fundamental. See, this I can say T0 is the fundamental period. T0 is what? Fundamental period. So that is the basic representation of any signal, periodic signal. T0, capital T0 is the fundamental period. Yes, this is this one. Clear? Let's go for the next question. Yeah, this is a good question. I'll read the question and I will give you 2 minutes of time to solve. Yes, if you are not in a position to solve, then I'll solve. What is saying? A properly shunted center zero galvanometer. What does it mean by center zero galvanometer? Suppose zero is there at the center. This is how it looks. Center zero galvanometer. Center zero. If this is zero, pointer will be here. If you do not connect anywhere, these values are negative. Suppose the galvanometer is reading some current. For example, let's take galvanometer is reading current from minus 10 to plus 10. So this is least current minus 10. This is the highest current plus 10. If I can say these are the readings, just randomly I'm drawing. Okay, I'm not taking 10 divisions equally. This is the pointer. If your current is negative, it is going to deflect in this direction. If your current is positive, that is going to deflect in this direction. Yes, till there it is clear. Means the center 01 will deflect for both positive and negative. If it is not center 01, suppose if I am taking 0 to 20 amperes ammeter or galvanometer, 0 to 20 amperes galvanometer, initially it will be there here. Only for positive current it will work. For positive current it will go this way. For negative currents it is not going to deflect. Small deflection it will make it to the left side and it is going to settle over there. Okay, right. What is saying? That is about center zero galvanometer is connected to the rotor circuit of a 6-pole 50 Hz wound rotor induction motor, slip ring induction motor. If the galvanometer makes 90 complete oscillations in 1 minute, that is very important. He's saying that the galvanometer is making 90 complete oscillations in 1 minute. 90 oscillations in 60 seconds. 1 minute means what? Or 1 minute. Let's take it as minutes only. In 1 minute. Okay. 90 oscillations in 1 minute. Okay. Induction motor. Calculate the rotor speed. He is asking about the rotor speed NR. We want this NR. Let's understand all this very clearly. What is the formula? NR is equal to NS into 1 minus S. NS into 1 minus S. What is NS? NS is equal to 120 F by P. 120 F by P. 120 into 50 by number of poles are 6 2 cities. Yeah, 620 cities. 1000 RPM is NS. 1000 RPM. We have rotor frequency from this data, FR. Yes, we have FR. Why? What is the rotor current's frequency? He's saying 90 oscillations, 90 complete oscillations in 1 minute. In 1 minute. But frequency is in terms of hertz. Hertz means per second. Number of oscillations per second. FR we have. Let's write the clarity about FR. Let's write clarity. Okay. What is 90 complete oscillations or 90 cycles? I can say 90 cycles in 60 seconds. Right? Then what is frequency? Number of oscillations in 1 second. Tell me, in 1 second, how many oscillations it is going to make? X oscillations. X into 60 is equal to 90. Therefore, X is equal to 90 divided by 60. Yes, it is 3. 3 is 3, 2 it is 1.5. The rotor frequency is 1.5 Hertz. Yes, rotor frequency is 1.5 Hertz. See, 90 oscillations per minute he given. Yes, I think I did not commit any mistake in the calculation or in the reading of data. He is saying that it is making how many? 90 complete oscillations. Okay, 1 means one oscillation means one full cycle. One oscillation means one full cycle. One full cycle we are taking. Number of cycles per second is frequency. Number of cycles per second is frequency. Here that fellow given 90 complete oscillations per 1 minute. Per 1 minute. 90 complete oscillations. 90 complete oscillations in 1 minute. Right? Now, in 1 second, how many oscillations it is making? 1.5. Frequency, rotor frequency is 1.5 hertz. Now, once we got rotor frequency, what is FR is equal to rotor frequency is slip times of stator frequency, that is 1.5, that is equal to S, I don't know. Stator frequency is 50 hertz. Stator is not going to rotate, the frequency of the currents or rotating magnetic field it is. So slip is equal to 1.5 by 50. Now if I use that, rotor speed NR is equal to NS. How much is NS? 1000 into 1 minus 1.5 by 50. Do this and you'll get the answer. Please, all of you, do this and tell me what is the answer you got. It's a simple question, okay? And this is the only question I found where you must do 1 or 2 calculations. This is also very simple. Don't think that it is tough. It is very simple. Yes. So it is 970 RPM. How much it is? 970 RPM. If you calculate, I did with help of calculator, 970 RPM, the option is C. Okay. People will think, sir, what to do with the center zero galvanometer in induction motor? So that galvanometer, why center zero is only using? Why not a normal galvanometer? One complete oscillation is looking for. Then only that is counted as a frequency, number of cycles. Otherwise, it is useless, right? Next question, please. Identify the non-renewable source of energy among the given option. Geothermal renewable, biomass renewable, solar renewable, but this nuclear is non-renewable. Nuclear energy is non-renewable. In our class, I given very clearly about this different types of energy sources: renewable, non-renewable, conventional, non-conventional. These things we discussed. Next question, please. Which of the following device does not belong to Thyristor family? SITH, it belongs to Thyristor. GTO, it belongs to Thyristor family. RCT, it belongs to Thyristor. UJT, unijunction transistor, is the one which does not belong to Thyristor family, which does not belong to Thyristor family, right? Next. In a magnetic circuit, the ratio of flux to MMF represent. First of all, what is flux? Flux is equal to MMF by reluctance. What that fellow is asking, the ratio of flux to MMF. Now, can I write reluctance? Sorry, flux to MMF is equal to very simply 1 by reluctance. Flux to MMF is nothing but 1 by reluctance. You know, reciprocal of resistance is conductance. Reciprocal of reluctance is permeance. Permeance. Okay. Reluctance means it is the opposition for the flow of magnetic flux. Permeance means there is the ability to allow magnetic flux, right? So answer is permeance. It is not reactance. Reactance is X. It is not resistance. This is also not correct. Reluctance, the reciprocal of reluctance. If he is saying MMF to flux, then it will be reluctance only. But flux to MMF he is asking. This is also not correct. This is reluctance. This is permeance. Answer is what? Option B. Right? See, till now, what are all the questions we done with the 2023, 2022? Now this is the last paper, 2021 paper. Okay, if any questions are left somewhere in between, we'll see in one more session. Okay, of these papers, one more session we'll see. Right? Yeah. Next question, please. Find the value of Z11 of the following is Z11. Z11 means what? See, this is port 1, this is port 2, this is 1 dash, this is 2 dash. Z11 is asking Z11. What people do is they try to remember some formulas and all that is not required. This is voltage V1, this current is I1, this voltage is V2, this current is I2, this current is I1 plus I2. Let's simply write KVL minus V1 plus 16 I1 plus 12 into I1 plus I2 is equal to 0. So V1 is equal to 16 plus 12, 28 I1 plus 12 I2. If I compare this one, V1 is equal to Z11 I1 plus Z12 I2. Compare these two things very clearly, then you get Z11 is equal to 28 ohms. Z11 is equal to how much? 28 ohms. Option C is the perfect answer for the given question. Option is C. Yeah, this is the question from control systems about Nichols chart. Nichols chart. What is the question? Read it. The critical point -1 comma J0 is mapped to dash on the Nichols chart. At a -1 comma J0, yes, gain margin will be 1 or 0 dB. In decibels, it is 0 dB. And phase margin phase margin is 0 degrees. Phase itself is okay. I'm not writing about phase margin. Phase is equal to -180 degrees. Yes, you see, -1 will be here. So this is 0 degrees. -1 will be this one. This is plus or minus 180 degrees. Now, if I'm moving this way, yes, here magnitude is, this is the magnitude, that is 1. I'm taking magnitude, I'm removing this minus, and the angle is -180. Angle is -180. If magnitude is 1, gain margin is 1, or in decibels it is 0 dB. So option is 0 dB comma -180. It is very easy question. Nichols chart and all these things are not there in the syllabus. And that fellow given one question in 2021 paper, right? Next, please. Last question. A 2 kilo ohm resistor is connected across 10 volt battery. Okay, there is a 2 kilo ohm resistance which is connected across 10 volt battery. 10 volt battery. Calculate the power consumed by the resistor. Direct question. See, I don't know why that fellow is giving this much simple questions. Power is equal to V square 100 divided by R, 2 kilo ohm. That is equal to 50 milliwatts. Option is A. Option is A. See, one thing I want to tell you here, that is in the HPCL examination, time is very important. Why? Because as he is giving very simple questions, for that see, questions are very simple. Everyone will get the answers. Time management is very, very important. And as I told you number of times, covering all corners of the syllabus is very, very important. Should not leave even a single theory point, single simple formula. Okay, you see, almost all the questions are very simple, fundamental questions. See, I will give you the guarantee which subjects you get complete marks. So these are the subjects you get complete marks. Networks, you will get full marks. Why? Mostly networks theory problems all are related completely. No much theory to mug, except in the chapters like magnetic circuits. Okay, where you have to remember about that dot convention, some formulas like M is equal to K into root L1 L2, KVL, KCL, sources, theorem statements about inductor, capacitor, those formulas. All those are means theory and numericals are much related. In fact, networks is a procedure-oriented subject. Okay, there you need not to mug much. Something you have to remember, but not that much. And signals and systems also, some questions will be given. That fellow did not mention separately this syllabus. He added in this networks itself, but those concepts are from the subject called signals and system. Okay, from this one also you'll get full marks. From there also you can get full marks. Okay, power electronics also you get full marks. Power electronics also you get full marks. Why? Power electronics also mostly only first chapter is theory. Completely first chapter is complete theory. Okay, there are some small problems, but mostly that question he asked, which of the following device does not belong to the family of thyristors, that is unijunction transistor. If you know all the devices that belongs to a thyristor family, then you can easily answer that one. There is no big rocket science there, right? So power electronics also you can easily get full marks. Some questions from analog electronics, small digital electronics, though implicitly they did not mention in very clearly in the syllabus, but 1 or 2 questions will come. Those also miscellaneous also you'll get. But where you have to put more concentration is power system. In power system, again, what are the topics? Topics like generation, transmission you can easily get. Topics like generation. In the generation, it is completely theory about turbines, about different kinds of power generation, nuclear, hydel, thermal, diesel, solar. In solar, again, there will be some of the things like related to solar materials, okay, how solar works, these things, and about nuclear fission, fusion, different kinds of materials used in the nuclear reactors and all, okay. Generation and protection and economics of power generation. From these areas, there is a possibility you are going to miss a mark. I'm not saying that this is the total syllabus of power system. No. In power system, we have stability is there, faults is there, transmission is there. From transmission, fault, stability, and distribution, definitely we get full marks. Why? Formula related or completely concept we can cover. But these are completely mostly theory. Therefore, you keep on reading these things from all previous exams like Indian Engineering Services previous papers, GATE 1 mark questions, other PSU exams. If you cover, you won't miss any mark. And from machines, electrical machines, yes, 90% you get full marks from this one. 90% you get full marks from that one. 10% mostly the people who prepared for GATE, they won't read or they won't study about 3-point starter, 4-point starter, the material with which starters are made up of. So this in DC machine, right? These kind of things generally the people who prepare for competitive exams, not HPCL, other competitive exams, they won't prepare. Suppose if you are writing ISRO exam, I never ask you to study about 3-point starter, 4-point starter, construction and its material. Operation, yes, it is required. But what material is used to make it, and if you go for commutator of a DC machine, what is the material used for commutator? In ISRO or GATE, this kind of simple questions cannot be asked. They won't ask generally. Okay, but in HPCL, those are important. Please go through those things. Okay. See, aptitude, Ashutosh, you can ask Jitendra Tyagi Sarma, aptitude. He is the India's top faculty for aptitude. Tyagi sir, I'm giving my number here. Okay, you just message me. I will forward Tyagi sir number to you. You can talk to Tyagi sir how to prepare for this aptitude. Okay, so my point here is there are few areas where there is a possibility definitely you are going to miss mark. So concentrate on those areas, especially the people who prepared for GATE. For them, there is a positive edge and negative edge. For the positive edge is they studied already some subject in depth. Negative edge is more negative edges for them. That is, they did a lot of big numericals. They expect that kind of things which are not going to come in the HPCL examination, and they keep wasting time in solving big numericals which are related for GATE, not for HPCL. Just you keep reading. If any big derivation, leave it. Okay, and EMFT is one subject which is very important. EMFT, all full marks you can get. Full you can get. Why? That fellow is going to ask most of the questions on Ampere circuit law, okay, Biot circuit law, or Maxwell equations on these things. Okay, electromagnetism, electrostatics, electromagnetism. These are the main topics. Definitely you get full marks. Concentrate on measurements. Again, in measurements also there is a possibility for you to lose mark. Why? Because in measurements also some questions related to theory, like which damping is used, where it is used, how it is used, what is the material used. Sometimes the questions about temperature. Okay, this kind of raw means a very rare areas is going to touch within the syllabus. Okay, sometimes he may go out of the syllabus also. Right? So concentrate mostly on machines, power system, and measurement, raw areas. I'm not saying not to read other things. You prepare other things also very well, but you concentrate more where there's a possibility for you to lose mark. If you have any questions regarding your HPCL preparation, you can directly message me. Right? And I'm ending this session. Thank you. All the best.